All right, math class, I need you to go get your math book, and we're going to write down some definitions. This week we are working on angles. It's really one of my favorite math videos. I'm actually going to make you guys watch it during this video to make sure that you watch it because it's so awesome. It's one of my favorite math videos. You guys are going to love it. So angles are so much fun. So we need to start out with a few different definitions. So go ahead and get your math book out, your notebook, your blue notebook, and we're going to write these definitions down. So the first definition is a ray. Now this is a part of a line that has one endpoint and extends in one direction without ending. So we've talked a lot about a line. And remember when we draw number lines, we go like this and we just say, okay, a number line is like this, and you can mark numbers anywhere on here. Well, a ray is different. A ray has an endpoint. So you'll want to draw this with it. Draw these pictures as you go, okay? It's going to go like this, and one line goes on and on and on and on. And one part of the end has an endpoint right here, which is actually, if you just go down one more, it says the point of the beginning of a ray is an endpoint. So draw it again. Here's a ray. My circle is kind of messed up. And then that right there is the end point, okay? This whole thing is a ray, but the end point is this dot at the beginning of the ray. So it means it can't go further in that direction, but a ray could. Like those lines kind of extend as long as that arrow goes forward, okay? You kind of have to think of that in your mind, but when it has an arrow there, it means it goes on as far as you need it to. Okay, the vertex. Now this is the shared endpoint of two rays. So if I have a ray that goes like this, and it goes up, that's not a very straight line. It should be a straight line. And then it also goes out. This point right here, boom. This dot, that's the end point of this ray, and the end point of this ray is the vertex. So if you also have a triangle, just so you know, because we're going to move into that, there are three vertexes here, because here is a shared endpoint right here. Oh. This is a shared endpoint right here. This is a shared endpoint right here. And this is a shared endpoint right here. These are the three vertexes where two lines come together. And even though those lines stop because they stop at the end of the next vertex and it doesn't have a line that goes on forever, anytime you have two lines come together like that, that's going to be a vertex. Now, an angle is made when two rays share the same endpoint. So this space in between, that is called an angle. So anytime you have the shared endpoint and you have two rays coming out, you're going to have this space in between those two lines is called the angle. So if you're looking at a triangle too, say we had this triangle. Oh my goodness, those are not straight lines. Here is an angle right here. This space between these two lines is an angle. Here's an angle right here between these two angles. And here is an angle right here. So every triangle, if you look at it, tri means three, right? And angle means angle. That's why a triangle means it has three angles. Tri, or three angles. That's why it's called a triangle, okay? So if you need to pause this to write all that down, go ahead. All right, then we're going to move into different kinds of angles that we have. So there are three different types of angles. We have a right angle, an acute angle, and an obtuse angle. Now, in our book, it doesn't give those, it doesn't talk about acute and obtuse. It just says bigger than and smaller than. So let's look at a right angle. That's the one we need to kind of think about first. And that is this one right here in the middle. A right angle has an angle with a square corner. And that's why you'll see this little square written. They'll do this all the time in a right angle. They'll give you a little square to say, if I was going to take a piece of paper, and maybe I could even do that. Say I was going to have a little sticky note, and I'm going to add it. I wonder if it'll let me do it right there. If I was going to move this sticky note and put this right in, I don't know if it's going to let me move it. Nope, it moves the whole thing. Okay, it won't let me move it. But if I was going to move this sticky note and stick it right in here, you can see this corner would line up perfectly with that corner right there. It would fit perfectly inside of that, okay? So that means that it's a right angle. If it's a perfect square, if it comes down and out, and there's an angle like that, that's called a right angle, and it'll always be marked with this little, if it marks it, it'll be marked with this. Now, an acute angle would be like, oh, it's so cute, it's smaller than a right angle, right? So if you have one, if this was a right angle, it would come up like this, right? And it would go out, and that would be a totally square angle. But an acute angle is an angle that is smaller than a right angle, or less than a right angle, okay? Now, an obtuse angle, so if this was going to have a right angle in it, this would go straight up like this, right? That would be a perfectly right angle right there. Oh my goodness. Let's try and draw that a little bit better. It should come out like that. But this one, it's not a right angle. It's bigger than a right angle. Okay, so it's bigger. It's greater than a right angle. It's an obtuse angle. Okay, so go ahead and pause the video. Make sure you have all those written down and draw the pictures for each of them. Okay, now I want to show you something on my website that you'll want to see. So if you go to my channel, it looks like this, and you can see all the videos that you need are going to be right here. You can go to videos, and it's got all of my videos on there, right? And you can scroll down and look at all of them. Those videos, you guys can't see. Those are private videos. Maybe I'll show them to you. This one is so cute. A little bit later. But right now, if you go to playlists, and you go to math, so there's a literacy playlist. That one shouldn't be in there. I'm not sure where that one's in there. But a math playlist. And you can say, click on View Full Playlist. And here are all of the videos that go along with our lessons. Well, we are going to watch this video because it's worth it. And then you can go back and watch it as many times as you want to remember. But it's also one of my favorite ones. So we're going to watch it.
Between 0 and 90, an angle is acute. This angle's small, skinny, and kinda cute. It looks like a V, or the top of a Y, or the angles that you see eating pizza or pie. Angles are measured in degrees, and here's how to remember them with ease. When an angle measures 90, do we call it right? You can tell this angle just by sight. It looks like an L, or the corner of a square. You're looking at it when you're walking up the stairs. Angles are measured in degrees, and here's how to remember them with ease. From 90 to 180, an angle is obtuse. This angle's kinda fat, it's got a big caboose. Like the hands on the clock when it's 1:45, or the antlers on the head of a full-grown moose. Angles are measured in degrees, and here's how to remember them with ease.
To measure an angle's degrees with a protractor. Place the vertex at the hole in the center. Line upon ray at 0 on the protractor. Remember that the 0 can be on top or under. Count up to where the other ray points at the number. That will be the angle's measure.
Angles are measured in degrees, and here's how to remember them with ease.
Okay. That one is, it's a classic angle video. Okay, so you can watch that anytime you want. And it is true, this is 90 degrees. So if I was going to say how much this, you're not really going to get into that much this year, maybe a little bit. But if you're going to say degrees, this right here is a little degree sign. It's like a little 0 up in the corner. So 90 degrees means it goes perfectly up and out. Like a perfect square is a 90-degree angle. Okay, so this would be less than 90 degrees. This would be more than 90 degrees. Okay, go ahead and get your math book out, and we are going to do our first lesson in chapter 14, which is going to be on page 833. So just go ahead to 833. I'm going to actually skip these 2 pages. Okay, so go ahead and get your book out. Now, if we read the very top of the page, let's just read through that again. So put your finger on where it says an angle, and let's just read it. It's not on here, but I'm going to read it with you. An angle is made when 2 rays share the same end point. A ray is a part of the line that has one endpoint and extends in one direction without ending. We just went over all of these definitions. An endpoint is the point at the beginning of a ray, and the shared endpoint is called the vertex. So in your book, you can kind of see the rays, the vertex, and the angle, and on the top it has a right angle. You can tell because it's a little square. Instead of a curve right there, it comes out and down, which means it's a right angle, 90 degrees. Okay, so we don't have geo boards. I mean, we have them at school. Obviously, we're not there. But this is where you take a rubber band and you go around and you make different angles with this rubber band hooked around the little pieces. So they said if you took an index card, which of course we also don't have with us, and you stuck it inside of here, this corner would go, like, make a perfect square, and that's called a right angle. Okay, so do all four corners of a square form a right angle? Could you put this square index card into every single corner and have it be a perfect square? Yeah, so that would be yes. Every single angle of a rectangle, because it means right angle, means that's what it means, is that every corner has a right angle, and a square is a rectangle. So all four of them are right angles. Now, this one, they want you to make a rubber band similar to this green pattern block. So if they're showing you in this picture, if you took that index card and you stuck it right there, is this angle going straight up or is it cutting across right here? It's cutting across, right? So that means that this angle is less than 90 degrees. So what did we say? We just learned the definition of that. What's it called? It's a what angle? An acute angle would be like, oh, it's so cute. It's littler. It's smaller, right? And if it was bigger, it would be obtuse. But how many angles in this triangle are less? If we turn this and if we move this and put it right there, is that one less? It is, because if it wasn't, it would make a perfect square corner right there. Is this one less if you're going to move that over? Yeah, because if it was straight, it would go straight up like this, right? So all three of those angles, you need to write that all three of those angles in that triangle are acute. They're all smaller than 90 degrees. Okay, this one, they want you to make a hexagon, which of course we also don't still have it, but a hexagon, hex means 6, remember? And so we have a 6-sided figure. Now, it wants you to compare an angle formed by 2 sides of the shape and find an angle that is greater than a right angle. So all of these angles in here are actually greater than a right angle, because you can see if you put this index card right here and you're measuring this angle, you can see it would be right angle if it went like this. It would be an acute angle if it came out this way, but it's bigger. It's an obtuse. So how many angles in there? Let's count how many angles are there. There's this one. That one's bigger. That one's bigger. That one's bigger. That one and that one. And how many angles are there? 1, 2, 3, 4, 5, 6. Isn't that interesting? That hexagon has 6 sides and 6 angles. Okay, same with the triangle. I think that we're going to see this a lot. A rectangle. Rect means a right angle, and there are 4 right angles in that. So we're going to write 6. There's 6 angles that are all obtuse. They're all bigger than a right angle. Okay, can a triangle have 2 right angles? I wonder if it can. What if we took our writing tool and said, okay, we're going to make a triangle with 2 right angles. So we have 1 right angle right here, and let's just make this right angle to go straight up like this. Okay, well, maybe we should erase that little piece. What do you think? It's not very straight right there. Okay, what if we had a triangle like this? Okay, we have 2 right angles. Is there any way to connect that to make it a triangle? Can we make that a triangle? Right now it's a 4-sided figure, and even if we went straight across, then it would be a rectangle, right? But as soon as you have 2 right angles, it can't be a triangle, because it's going to have to be a quadrilateral, because the only way you can connect that is by making a 4-sided figure. So let's see what they had for their answer right there. Nope, the shape would not have all 3 sides connected, right? You either couldn't connect it, or to connect it, it would make it a 4-sided figure. We didn't do this part. A right angle, the corner of a doorway. What about a window? If I had a window, the corner of a window, that could be a right angle. You could say the corner of this computer screen is a right angle. So just think of something that could be a right angle in real life. There's lots of them. Okay, this is what I decided to have you guys do. These are your 2 pages that you are going to have finished and turned in. And this is on my website. But it's 8:35 and 8:36. I want you guys to answer all of those questions. And what I decided I would do is I'm just going to pause the video for a minute after you do that, or after you do that, pause the video, and then come back and I want you to check your answers. Okay, so all of your pages that you need to turn in need to be self-corrected. Make sure that you actually do the work first and trust in you to do the work and then come back and check it. But if you got it wrong, I want you to write on your paper why you got it wrong and what the right answer would be so that you can be figuring that out. Like, oh, that's our best part of math, right? When we're like, oh, I got that wrong. Oh, I see why. And if you don't see why you got it wrong, then I need you to leave a comment in the comment area and say, I don't understand why I got number 4 wrong. I thought it was this, but it wasn't. Okay, so go ahead and pause the video now. Okay, when you come back, we're just going to go through what our answers are. So it's talking about if these angles are a right angle, less than a right angle we know means acute, greater than a right angle we know means obtuse, but we're not using those definitions. We're just going to say less than or greater than. So this is less than a right angle because if it was a right angle, it would come out like this, right? And then it would form a square, right? And they actually give it away because they put the little square in there when it's a right angle. So you know that one is a right angle because it goes up and out and it's a perfect square. If you look at the next one. Okay, so it's saying this little angle right there. You can tell that one is actually really little just by looking at it, right? You can tell that's less than a right angle because it looks small. And this one's a perfect right angle because they give you the square. As soon as they put that little square in there, you'd be like, oh, right angle, easy. Okay. Now, what about this one? Is this one bigger? You can just tell right now that this would be a right angle and it's already bigger than that. So that one's going to be greater than. And this one you can tell is smaller than because if it was not, it would be going straight up and down. If it was a right angle, and it would have the square on the inside. So that's greater than and less than. Okay, same thing. And if you wanted to take a piece of paper, so say you wanted to just take a little piece of paper and you stick it in the corner and you just like put it right in the corner right there to see if it's a right angle, any paper should work and you should be able to put it in there to see if it's a right angle or not. So that one is obviously greater than. That one is a perfect right angle or 90 degrees. Okay, Claudio noticed that the sides of his $1 bill formed angles. Tell whether the angles are right angles, less than, or greater than. So every one portion of his $1 bill, I wish I had one. Think of even your Philpot money that you get in class, your Scholar dollars. Every corner, what is it going to be, a right angle or not? Or a bigger than or smaller than? All corners are right angles because each corner forms a square in a dollar bill. That's a square corner for each of them. Okay, we have these 4 shapes on the board. Circle the shapes that appear to have one or more right angles, so it can have more than one. Okay, so this one has how many right angles? It has 4. Does this one have any right angles? Nope, they're all acute. They're all smaller. Does this one have any right angles? No, these 2 right here are smaller, and these 2 look like they might be obtuse. They're a little bit bigger, right? And same with this one. These 2 are acute. And these 2 are obtuse, they're bigger. Right, so there's only one that has right angles in it. Okay, draw 3 shapes, each showing a different type of angle. Mark each angle and label it. So I want a right angle, an acute angle, and an obtuse angle. There you go. Now you could do triangles that show those. If I was going to do a triangle, I'm just going to show you. If I was going to do a triangle like this, and then just right there. This would also fit into that category, right? Or if I wanted to do a little teeny triangle like this, that angle right here would be a less than a right angle. Okay, so you can do a triangle or you can do a different shape, whatever one you want to try. Okay, circle the 2 angles in the figure to the right that appear greater than a right angle. Okay. Which 2? Go ahead and try that. Well, you can tell that this one and this one are smaller. And this one, if I was going to say this was a perfectly right angle and it was flat on this side, I'd be like, well, it would have to come up. Oh, goodness, that's not going to work. Try that again. It would have to come up perfectly straight right there. This would be a right angle, right? So does that look like it's bigger than one? Yeah, that one is bigger than. And this one is the same angle actually, because if this is my flat side and my angle is going to come down like that, that would be a right angle right there. So this one is also going to be bigger. Okay, you can just say they both appear to be bigger than a right angle, and they both are. How can I tell if a angle is a right angle? Try and write a sentence for that. Pause it if you need to. Okay, so you can take an index card or anything with a square corner and line it up inside. So you line up this, you line one side against the bottom flat side, and then you look at the other side and see if it's straight up and down, or if it comes out, or if it's on the inside to form that angle, okay? All right, you don't have to do your homework pages, but if you want to, you can. And it's really best if you just turn all of your work in and at the end of the week all together. Make sure you get your test done. And if you have any questions, leave some comments for me or go ahead and email me, and I'll post the next one in a little bit.